You know that feeling when you're in a Google Doc and you can see your teammate typing at the exact same time as you? It feels like magic, right? Well, today we're going to pull back the curtain and look at the incredible tech that makes all that real-time collaboration possible. It's called a conflict-free replicated data type, and trust me, it's as cool as it sounds. I mean, really think about it for a second. We've all seen it. You're working on something and poof, someone else's cursor just appears and starts moving. Their words show up on your screen almost instantly. How on earth do all these different computers, maybe thousands of miles apart, stay so perfectly in sync? What's the secret sauce? Yeah, for most of us, it just works. It feels like pure magic. This seamless, instant collaboration has totally changed the game for how we create things together. We're doing everything together now, right? Co-writing reports, designing stuff in Figma, even just group chats. We're all jumping in, making changes at the same time, and somehow the system just handles it. But let me tell you, behind that super smooth experience is a huge technical problem. So it's time to meet the villain of our story. Let's call it the Great Syncing Problem. This is the big scary monster that every single developer has to slay if they want to build an app where people can work together. Here's the deal. If you don't have a super smart system and two people try to change the exact same thing at the exact same time, you get chaos. We're talking a total mess. Data gets overwritten, things get lost forever, and you end up with a corrupted file that's basically impossible to fix. It's a developer's worst nightmare. Okay, let's make this super simple. Imagine you and I are editing the same sentence, but our Wi-Fi cuts out. I change the end of the sentence to say is blue. You, on your computer, change it to is red. Now, what happens when we both get back online? The app suddenly has two totally different versions of the same sentence. And conflict, right? Which version is the right one? Is it mine? Is it yours? Does the first person who reconnected win? The last one? Should it try to guess and merge them? See, without a rock-solid set of rules, the system is completely lost. It has no idea what to do, and your data is basically toast. But don't worry, like any good story, this one has a hero. And the hero is this absolutely brilliant concept designed to solve this exact problem. Let's meet our hero, the conflict-free replicated data type, or as we'll call it, a CRDT. This isn't just some patch or a workaround. Based on a really smart paper from 2011, a CRDT is a special kind of data structure that was built from the ground up for one purpose, to be copied across a ton of different computers and updated by anyone at any time without breaking. So CRDTs basically have three superpowers. First off, anyone can update their own local copy of the data whenever they want, even if they're offline. The system is optimistic, meaning it just says, sure, go for it. We'll figure it out later. Second, there's a built-in mathematical magic that automatically sorts out any conflicts. No need to ask a central server what to do. And third, this is the big one. They guarantee something called eventual convergence. That's a fancy way of saying, sooner or later, everyone's copy of the data will end up looking exactly the same. Okay, so how in the world does this actually work? I know, it sounds super complex, but the basic idea is actually pretty clever and not as scary as you might think. It really boils down to two main flavors. So you've got your two main types. Think of it like this. State-based CRDTs are kind of like sending the entire document to everyone every time you make a change. Then everyone's computer merges the whole thing together. Operation-based CRDTs are a bit more efficient. They just send the specific change you made, like I added the word hello here, or I increased this number by 1. Everyone then just applies that specific instruction. Let's check out a super simple example to see this in action. It's called a G counter, which stands for grow only counter. So imagine we have 3 people, user 1, user 2, and user 3. Each person gets their own little counter in a list. So user 1 has clicked the like button 3 times. User 2 has clicked it 5 times, and user 3 has clicked it twice. Each one only updates their own slot. Now to get the final total count, we just merge everything. And the rule is dead simple. For each slot, you just take the biggest number you've seen for that slot across all the users. That gives us a final list of 3, 5, 2. Add them up and you get 10. And here's the magic part. It doesn't matter what order the updates arrive in. The final answer will always be 10. See? No conflicts. Now, you might be thinking, okay, that's a neat little computer science trick, but this isn't just some theory and a textbook. I can pretty much guarantee you have used a CRDT probably in the last hour. They are the invisible engine powering so many of the tools we use every single day. You know, when you're on the subway with no signal and you edit an Apple Note on your phone, and then later, when you're back online, it just magically syncs with your Mac? Yep, that's a CRDT, making sure your changes get merged perfectly. And Microsoft, they are all in on this stuff. Their entire Fluid framework, which is the tech behind all the new real-time collaboration in their apps, is built from the ground up on CRDTs. Anyone who's a designer knows Figma, that amazing multiplayer feature where you can see everyone's cursors flying around designing in the same file at once. That's powered by the core ideas behind CRDTs. And then you have the absolute behemoths. At Facebook, they use CRDTs in some of their most critical systems, like their Apollo database and even the internal tools they use to manage the social graph itself. We're talking massive, massive scale. But if you want a number that will just blow your mind, look no further than Riot Games. The chat system for League of Legends, it runs on CRDTs, and it is built to handle, get this, 7.5 million people all chatting at the same time. That is just an unbelievable scale for conflict-free collaboration. So where does this leave us? What's the big picture here? Well, as we all work more remotely and need our tools to be more collaborative and work offline, the ideas behind CRDTs are becoming more and more essential. This quote really nails it. CRDTs are ideal for optimistic replication. Remember that optimistic idea we talked about? It means an app can just accept everybody's changes right away, without waiting. It can do this because it has a mathematical guarantee that it can sort out the mess later. And that is the key to building the fast, offline-first apps we all love. So the big question is, now that we have this incredibly powerful tool in our toolbox, what's next? Now that we can build these super resilient, super fast, offline-friendly collaborative systems, what's the next giant problem we can solve with them? What new ways of working together can we invent? The future, as they say, is convergent, and I, for one, can't wait to see what we build.